Hello, I'm Noah Moore. I'm going to be talking over stability control. So, what we talked about in class yesterday, 4/9/24. So here we got a system that's unstable. So the equation is x dot equals ax, where a is positive. And so we got a positive sloping line. Here our equilibrium point is at the center where x dot is equal to 0. And so this line is unstable, or this graph is unstable because it crosses in the first and third quadrant here. The equation for this to show it's unstable is x dot equals a x e plus delta x. And so this shows just how it's unstable. And so here we know x e is equal to 0. So this equation is now x dot equal to a delta x. And so here, when you give it a nudge one way or the other on the line, it's going to compound and it's going to want to move away further from that equilibrium point. Because this a is positive, so if delta x is positive, it gets pushed this way, it's going to work its way down the line and stay unstable. Here, our stable graph is different. So here a is negative, and so here on this chart, it's using the same equation to show it's stable, but in this case, since a is negative, and if you give delta x a positive push this way, then the line's going to want to go back and stay at this equilibrium point. And then here's just a couple stability equations, or kind of charts here showing it. Here we have an unstable system, and so unstable is going to go more up and stay up, and it's going to go down when you give that nudge. Then we got a static stable but a dynamically unstable graph. And so this one here is where it goes down, comes up, and at the beginning it wants to stay kind of stable, but the further it goes, the more dynamic it gets, the more unstable it gets. So our last here is a stable graph, and so it wants to stay along this equilibrium point. So it starts oscillating a little bit, but it levels out and stays stable the rest of the way. So thank you.